Alright, let's solve exponential inequalities. Okay, so we have a number line. We will visualize the number solution set, and then we will write the solutions. Let's do all questions briefly. So from the beginning and 3 to the x power, let's add 7 on both sides. You can get 27, right? If you want to solve an equation, that's fine. You solve an equation, setting up equal sign in the middle and find the boundary number. If base is higher than 1, you can keep the same bases when you do the calculations. So let's think. 27, that number is familiar, right? Okay, can you rewrite 27 as base 3? 3 to the power of 3. So we need to compare only the exponent because bases are same and base is greater than 1, so I can just compare the exponent, and that's going to be the answer. To make sure, and I'm going to visualize this, and then I'll graph it, greater than on the right hand side, and let's check with one number in that solution set. Pick a number. 5. Okay, let's plug in 3 to the 5th power, subtract 7. Is that greater than 20? Yes, it is. So that is the right side. So that is the solution. How do we describe the solution set? In inequality notation like that, or we can use set builder notation like this, or we can use 3 to infinity interval notations like that. So any of the form is fine to describe this solution set. Can we do C first? Alright, so let's do the problems. 2 times 2 to the 2x power. You see, I'm breathing in and out, and I see number 2 and letter E at the same time, right? Okay, 2 times e to the 2x power plus 1 is less than 33. So let's say subtract 1 from both sides. What do I get? 32. Alright, let's divide both sides by 2. So this will be 16. Now I notice that I cannot rewrite number 16 just like above. Okay, we cannot write number 16 as base e because base e is irrational. So I have another idea. Let's rewrite this form. How do we rewrite? So this input will be output, and I need to change exponential form to logarithmic form. Which log do I use when we have base e? ln, that's right. And then input will be output 16. Do I keep the same direction of this inequality, or do I need to reverse it? It will depend on the base. Okay, base is greater than 1, we still keep the same direction. If you are not sure, you can equate it, and then you can find the equation first, and then we will check which side goes with the solution set. Okay, so that's all right. So let's calculate what is ln 16 and divide by 2. What is the number we got? 2.77 approximately. Okay, and then let's use 2.77 approximation, and let's take the part. Which side do I go to make the number bigger? Is it right or not? Oh, this is not bigger. That's less than 33. So is it going to the other side? Can I use negative number? Yeah, that's right, right? Negative number is okay because this is exponential function. Domain is all real numbers. Okay, we found the mistake here, and ln is 2.77, right? And then let's divide by 2. So 1.39. Okay, so let's go with 1.39. So pick any smaller number than 1.39. And then let's test it. This is the inequality. Test it. Is it less than 33? Yes. And then that's the solution set. So solution is between negative infinity to 1.39. Both of them are excluded. Okay, not included. So that is it. Now let's look at question B, and let's try to do the problems. So let's rewrite it. X minus 3 input will be output, and I need the logarithm with the base 5 and number negative 40, right? Oh, I have bad feeling. What is the meaning of logarithm negative 40? Logarithmic function has domain restriction. Domain of the logarithm function is x is greater than 0, right? But I have a negative input, so whoa. So if you use calculator for that number, you will have error, right? What do I do then? If I have no number on it, what can I do? So let's think about doing different way, okay? Left-hand side is going to be a function. What kind of function is this? Exponential function. So let me use a calculator and let me graph this as y1, okay? And the other side, what do I have? Number. So this will be a constant function, which is a straight line, okay? So let me set it as y2. If I grab both of them, I can see both of them, right? But if you have negative 10 to negative 10, you cannot see it, so adjust the window. So let me draw roughly y1. When you graph y1, you have, it's increasing, isn't it? 5 is base, so base is increasing. Base is 5, and the graph is increasing, exponential function like that. Move to the right 3 units, okay, 1, 2, 3, like that, right? All exponential function has horizontal asymptote, right? So this is y equals 5x to the x5 to the x minus third power. I can write it. Okay. And this is the, it's spinning. That means I can do anything at all on it. All right. This is the horizontal asymptote. What is the horizontal asymptote of this function? Y equals 0. And then let me use different color for y2, okay? I'm going to construct y2, which is a constant function, go all the way down 40, okay? And then there is a straight line here at negative 40. So this is y equals negative 40. And we are looking for any x value making this sense, okay? So the top one, blue one, is greater than or equal to negative 40, which is the purple one. Is it greater than or equal to everywhere? Yes, it is, right? So answer will be all real numbers. All real numbers. So you can shade everywhere. All real numbers, that is it. Is it confusing? And I'm not saying no solution because this one doesn't make sense here, okay? I need to think about different way of solving it. So I grabbed it, and then I noticed that the blue one is always above than 0, actually. So it is automatically greater than negative 40 all the time. So all real numbers can go in x place. So solution for this inequality is all real numbers. In all real numbers, this is a true statement. Make sense? Okay. Now let's do number 4D. Okay. First of all, what do I need to do? Add 2 on both sides, right? 245. And then what's next step? Divide both sides by 5. So 245 divided by 5, what do we get? 49? Okay. And now I cannot write 49 in terms of in the base of 4, okay? So I need to rewrite this. So let's write it again. Input will be output, output will be input, exponential form will be logarithmic form. So let's take the logarithm with the same base number 4 of 49. So you use a calculator to find this number, and then we will proceed. So you can find x value. So use calculator to evaluate this, and then subtract 1, and then divide by 2, and we'll have a boundary number. Okay, now we have number 0.5. 90. Okay, so here 0.90, and in inequality we have equal sign, so we use closed circle and to the right. Can I choose any number to plug in to test this region as a solution set? How about number 1? Number 1 is higher than 0.9, so plug 1. 2 times 1 plus 1, that's 3. 4 to the third power, 64 times 5, 64 times 5, 320, subtract 2, 318, right? Is it greater than that? Yes, it is. So we will take the right hand side, okay? So if we have a higher than 1 as a base, we just keep the same direction of the inequality. But if it bothers you, you can solve the equation and find the boundary numbers and take the side by checking the number. That's how we solve exponential inequalities.